Hey, this is OXDF. Today we're looking at the last day, day 25, clock signal of the advent of code 2016, revival of code 2023. Let's look at the challenge. Bunch of story here, antenna, blah, blah, blah stuff. The real thing comes out to, we have a computer, and it's the same computer we used in day, I think 12, and then again in day 23. We might have used it a couple times. And we got the same computer, and it's got a new command. It's got now an out command that transmits an integer value, an integer of at the next value of the clock signal. So my goal is to produce a constant 01010101 signal. And so I've got my puzzle input, which is going to be my assembly, and I need that to produce alternating ones and zeros infinitely. And it needs to know what is the lowest positive integer I can use to initialize register A to cause the signal of 0101 repeating forever. So that's the question. Let's jump over here. I'll use my genday script here for day 25 to pull the input and make some stub Python files for me. They don't give us any tests here. There's nothing I can test. I guess I could run some experiments and then use tests to lock them in, but I think for practically speaking, we're just going to get rid of the tests today because there's nothing to test. So that's gone. Input. So we've got this assembunny language that they've given us before. And I actually wanted to spend some time with this today. I'm going to see if we can make this. Let's split this to the right. Let's get ourselves a new file here. What I wanted to do was to say, let's go through and actually do some analysis of the bunny. Day 25 typically only has one challenge. There's no part 2. So I want to solve this 2 ways. Let's see if I spent a little time looking at this before starting the video, and I think we can solve this pretty quickly with some pseudocode. So if we look through the lines here, we can see the first thing is going to say D equals A, and A is our input. And then we can say C equals 4. Hopefully this lines up. Let's see. I wonder if I need to save this as something to get it to, let's see, save. Notes. Sweet. Okay, so now it's lined up nicely here. I'm even going to scoot this over even further so they're closer together. This one says B is equal to 643, but before we go too far on that pattern, we can actually recognize this pattern we did study in depth on day 23, right here. In fact, is it all of these? Yeah, it is. So what we have here is the pattern. I went into it in detail in day 23, but basically it's going to say, we're going to increment D, we're going to decrement B, which is 643, and then if B is non-zero, we're going to go back up and do it again. We're going to do it again. So we're going to add 643 to D, boom. Then we go down C, and we jump back up 5, and we do that whole thing again. So effectively 4 times 643. So what we're going to really do here is we're going to say D plus equals 643 times C, which we know is equal to, the best way to say that is it's going to be 643 times 4, which is, don't know off the top of my head what that is. Python 643 times 4 is 2572. Cool. Okay, put that there. So we know that, and we can now skip that. All of that is just doing that. So now we're back down here to line 9. Let's go to line 9. D is equal to A. Nope, sorry, backwards. A is equal to D. So we've saved that value into A. This is effectively a no-op, jump non-zero. So it jump non-zero zero lines. It just does nothing. So we're going to go now. Copy A into B. So B equals A. Copy 0 into A equals 0. The next one is going to be copy 2 into C. So C equals 2. Now, jump non-zero if B down to is 2. Basically what this is saying is if B is 0, do this thing. So I'm going to kind of combine those two lines. So B equals 0. And then this one's going to be go to 15 plus 6 is 21. Okay. Now we're going to dec B. We're going to dec C. We're going to jump. If C is equal to 0, we're going to go back up 4. So from 18 to 14. So back up to this B check. So if C equals 0, go to 27. Inc A, like that. Now jump non-zero 1. So we're gonna always make that jump back up 7. So up to 13. So this will go to 13. So with this little loop, can we do some analysis on what's going on here? And this is tricky, but this one, I looked at this for a few minutes and kind of ran through it in my head before we started recording. And basically what we're going to do is C is going to be, you can see this loop right here is really around this. And let's see, is this right? We go to 27 and 21. Is this jump? Yeah, I guess that's right. Okay. So it bumps this out, and this one is not going to go to 27. It's going to, I don't know where I got that from. If C equals 0, we're going to go -4, so 14. That makes a lot more sense. So we're going to start off by putting putting the value we care about, the thing we've been tracking, which is this 2572, into B. We are going, well, 2572 plus whatever our initialized A was. That's worth noting. We're going to put that into B. If B equals 0, we're going to break this loop. So we're going to do this loop till B equals 0. And each loop, it goes down by 1. Now we're going to set C down by 1. And if C equals 0, we're going to go back up here and check B again and return and potentially break out. Otherwise, we're going to subtract. If C equals 0, go to 14. Oh, it's if C is not equal to 0. That makes so much more sense. Okay. If C is not equal to 0, we go to 14 and we check B again, and then we decrement B and C. And if once C is equal to 0, we add 1 to A, which was initialized to 0, and then we go to 13 and we set C back to 2 and do it again. So what this is really doing is this is effectively saying, give me, I'm going to keep taking away 2. I'm going to count how many times I take 2 away from B before B equals 0. And C is going to be the kind of, I'm going to say the remainder, but it's not really the remainder. It's either going to be, it's going to be like 2 minus the remainder. Yeah, it's going to be 2 minus the remainder. So we have a way to count. So C is going to leave here like that. So I almost want to do, we need to do this another one, split right. Okay. Let's scooch this around here. Here. Let's make ourselves a new one here, and we'll call this like save notes 2. I'm just saving it so I get the lines lined up. So effectively what we're going to say here is D equals A plus, what did we say this number was? 550. This number here. And then the next thing we're going to do down here is we're going to say, way down here, we say A equals B. And now we're basically going to say, coming out of this thing, B is going to be equal to 0, because that's the only way we break. C is going to be equal to 2 minus, I guess we should set the B equal 2 minus A mod 2. So that's our A. A is equal to D divided by 2. And I think that's it. So that's effectively what we're gonna be doing here. We're gonna set these things and D doesn't change. D just holds this value. Okay, so now we're down. I don't know why I should get rid of this. Stop scrolling. Scrolling's gonna screw up our synchronization. Okay, so now we're here. We've broken out here. Here we're going to say B equals 2. If, did I skip anything? Yeah, okay. jump non-zero C is 2. So if C equals 0, then we go to 24. So basically this is if C is not equal to 0. No, sorry. If C is equal to 0, we do this next thing, which is we definitely jump forward 4 to 27. So we're going to do go to 27, which is down here. Now we're going to do our same kind of B minus equals 1, C minus equals 1. Jump non-zero, definitely not going to be 0. So jump, this is going to be go to 22. Jump non-zero, 0 is a NOP. We'll say out B. And then here we say if A is non-zero, A not equal to 0, go to 10. And then we have go to 9. So effectively at the bottom here, if A is not 0, we go back up to 10, which is this NOP. If A is 0, we reset it to D, and then we do it all again. So this is going to be kind of an infinite repeating loop. We're always going to be doing this loop. So what have we done now is we've divided A in half. What is this next thing going to do? And this is, so we have, let's see, where do we pick up here? Right here, I believe is where so we set B to 2. If C equals 0, which means that A mod 2, I don't know how C can equal to 0. It can't equal 0 right away. Then we subtract B and we subtract C. So now we get down to B equals 1 and C is either going to be 1 or 0, because it's going to be 2 or 1 to begin with. So now it's 1 or 0. And then we go to 22 and check C again. And so now this time we now have go to 27. So we're out in here and we output B. Effectively what this is doing is it's saying B is equal to 2 minus C. So we can come down here and just say B equals 2 minus C. So effectively B is going to be equal to A mod 2. And that's cool because now what we have is basically the bit of the remainder when we divide it by 2 gives us the low bit in the number. And that's cool because then, and that's what's getting output. So we can kind of even sum all this up basically by saying while true, A equals D, and then we'll say while A not equal to 0, make some more space over here so we can see it. Didn't need a breakpoint. Scoot that over. Well, A is equal to 0. We're going to say A is equal to D divided by 2. I guess it's actually going to be equal to A divided by 2. We divide by 2. I guess we should probably do this like this so that we can see both at the same time. B is equal to A mod 2. So there we go. So we're going to update that, and then we're going to print B. That is really it. That's our whole thing right there. So effectively what we're going to do is forever we're going to say take A, and we're going to get the bits off of it. And what's cool about that is then we need to find the first thing that's greater than 2572 that has this repeating 101010 pattern. And we can do that by pulling up a terminal here. And in Python, we can say, well, we know, let's see, we'll do a format string on 2572 in binary and see what that looks like. So let's see, what's the length of that? Length is 12 bits. So we need something that's at least 12 bits. And so we can say, what is 10 times 6? That's our number right there. That's our 12 bits of 10101. And so we can say int comma 2 of that. And our answer is 2730 minus, we'll subtract off the 2572. And our answer is 158. In fact, we can go solve right now and get that answer. I'm going to hold off on that for a second because I'm going to actually do the programming as well. We'll see if we can verify it. So let's see. I'm going to close, and do this the programming way. We'll grab our computer from day 23. From here, we need our class computer. I'm going to leave in some of the speed ups. We could even write some more speed ups if we wanted, but we won't. Let's leave it at this. Let's see, we will pull this down. We need that, put that here. Okay, so now we have our computer class. We're going to need from collections import default dict. We're going to need import re. And now the other thing we need to do is implement this output command. So what I'm going to, and we're going to use it for a little bit more than output. Case out. And so what are we going to do? We're going to say, we'll say like value equals self.get value of t1. So we get our first value out of here. And if you're not familiar with this computer, I recommend you go back and watch the previous videos. I'll make sure to include links in the description here, where I made the computer. So we can say if val not in 0, 1. Now, I think we know from our analysis that that's never going to happen, but let's just pretend we don't know that, because we wouldn't know that if we were solving this way. And then we can also say like, oh, let's come up here and do self.output equals that. We're going to keep a list of the output. So now we can say if self.output, so if self.output exists and self.output of -1 is equal to val. So if we're putting out the same thing, we know we're only going to have zeros and ones at the point, otherwise we've already returned false. And so if the last thing in output is equal to the next thing we're trying to add, we'll return false. Really, we just want to break out of it. We want to be done with this function if we hit that. Otherwise, now we know if we've gotten a valid next thing. So we'll say output.append val. And then we need some way to break on the positive side. So we can do something like if len self.output. I don't know, like what's a good, like is greater than 50? I guess technically we know we hit it. Well, we know from our analysis we hit it if we're greater than 12, but let's just do 50. Seems like a good true. So like that. Because if we pretend we don't know how this is being generated, that's fair. Okay, so now we have an out that's going to sort of generate output and eventually return either if it's got bad output or good output. So now we can come down here into puzzle and we can say comp equals computer puzzle input. And we'll do computer, let's see. I guess we'll say a equals 0 while true. Computer equals, we better create a new computer down here. Because I want to make sure we reset everything. So we create the computer, we'll do computer.reg a equals a. We'll say if comp.run. If we run it and it returns true, we will print, we'll just break here, because that'll tell us that we know A. And then if we didn't do that, we will print like A doesn't work. And then we can say A plus equals 1 and loop around here. Let's see, we're just going to get a little bit confident here and say no challenge part 2 today. And part 1 is just going to be A. I think we may solve it right there. In fact, let's do some, we can do some pretty printing here. We can do reset our screen, our terminal here. So this will all print on the same line and equals like that. And then if we do print nicely, we will do a print \r, and we'll overwrite a bunch of stuff to make sure we clear all that out. And \r, comma, end equals like that. Oh, no, not end. Yeah, end equals that. So that should effectively clear it and reset it so that when it does write at the end, it's happy. That looks reasonable. Let's give it a run. We have an error in here somewhere. We're missing an open parenthesis. That helps. I guess we should just pay attention when there's a bunch of red underlines. You should actually like pay attention to it. We should probably run this outside of the debugger, but you can see we're already climbing up pretty quickly. And feeling if we hit 158 here, hopefully we're going to get an answer. Boom, we got the answer, 158. So both of our methods of solving this agreed. We got the answer. Continue to part 2. Basically now once you've got stars and solid 10, only 49 to go, you have enough stars to transmit the signal. and we get our 50th star. So cool. That was Advent of Code 2016. Thank you to the Python Discord for organizing this and putting on. I've had a good time. It was a nice little break in July and August to get to do some coding and create some videos. And thanks for watching. I appreciate you hanging around to the end. It's a great way to support my channel. And I will talk to you next time.